Thanks very much again and welcome to our next clip as we continue with our mathematical series. Here in this class, already in our previous class, we have considered polynomials, what polynomials are. Here in this class, we're going to round up by considering polynomial factorization. Polynomial factorization. Polynomial factorization. Now, already we have been told what polynomials are, and at least we are also able to evaluate them at a particular point, evaluating them at a particular point. Now in this case, we are going to factorize, we are going to look for we are going to look for simple linear factors, simple linear factors in the polynomials, such that when we evaluate those things at that point, the entire system becomes zero. Once you are able to look for factors such that when you evaluate the polynomials at that point and the entire system becomes zero, then you say that those expressions, that the linear factors that we are going to have are factors of that polynomial. Let's consider some cases, simple cases, and we're going to start some examples to illustrate this idea. Examples. We are going to consider things like A. Let's say we are going to consider x raised to the power 3 plus 6x raised to the power 2 plus 5x minus 12. We are going to consider another one, say B. 2x raised to the power 3 minus x squared minus 10x plus 8. C, we are going to consider 3x raised to the power 3 minus x squared plus x plus 5. Then we are going to, again, D, consider x raised to the power 4 minus 5x raised to the power 3 minus 15x squared plus 10x plus 18. E, we are going to consider 4x raised to the power 4 minus 4x raised to the power 3 minus 30x raised to the power 2 plus 45x plus 18. 10x, sorry, this 10x is plus 8, this is plus 18. Then F, we are going to consider x raised to the power 4 plus 2x raised to the power 3 minus 6x raised to the power 2 minus 2x plus 5. G, we are going to consider x raised to the power 2 plus 5x minus 14. H, we are going to consider 2x raised to the power 2, 3x minus 5. Now, all these that we have presented here from our previous class, we have been told that they are all polynomial expressions. They are all polynomial expressions. This one, the highest power is 2, so we can say that it's a polynomial expression of degree 3. The highest power here is 3, so we can say it's a polynomial expression of degree 3. And in another word, you can say it's a cubic expression, but it's a polynomial because you can see them and all the powers are all natural numbers. Here in this case, is also the same, is also a cubic expression. Here is also a cubic expression. Here is a quartic expression. Quartic. These are rather quadratic expressions. But all these that we have here, even as they are polynomial, they are all polynomials of a single variable. They are all a polynomial of single variables. Now let's try to, our interest here is to see how we can factor them, how we can have linear factors of these things such that when we evaluate those answers at that point, the entire system becomes zero. And I know in our previous classes when we were dealing with quadratic equations, we have done the similar thing by solution method by factorization. And we are going to just refresh our memory with one of these. Then we will dive into the other cases when the power is more than that of 2. Let's consider this example that we have, where we have this is a function of x, and we have it to be raised to the power 2 plus 5x minus 14 minus 14. Now, in this case, in our method by factorization, we said we are looking, we would have, for us to do this, we said we would have considered that of the discriminant to see if the discriminant will be a perfect square. But straight away, the concept is, think of two numbers such that when you multiply them, it will give you this multiplied by this. Now, this multiplied by this is negative 14x squared. Two numbers, and when you multiply, it will give you negative 14x squared. Now, those same numbers, when you add, it will give you plus 5. Now, if you think of those numbers are just simply negative 2x and plus 5 and plus 7x. So this expression can also be written as this, negative 2x plus 7x. This to this will give you 5x, and when you multiply them, it will give you negative 14x squared, negative 14. This is what we have. So you can see that we can factor this out. This by this will give you this, minus 2. When you use this to multiply this, you have this. And we also have 7 plus 7 into x minus 2, because we have been told that the bracket, the entities you have in the bracket here must also be the same here. So in this now, we just have those things outside, which is 7, and one of these brackets, which is x minus 2. So you can see that we have succeeded in factoring this. And here we have our x is up, our x plus 7 is equal to 0, or you say x minus 2 is equal to 0. And x here is negative 7, or x here is positive 2. Now, the point we are making is, if we evaluate now this when x is this, at this, the entire system must go to 0, must be equal to 0. If it's equal to 0, then we say they are simple linear factors of that polynomial. Now, let's try that. Let's evaluate them to see if it works. F of negative 7 in this case, will be, if you put it here, we have negative 7 raised to the power 2 plus 5x. Anywhere we say x, we are putting negative 7. So, minus 14. What will be the answer? This times this, negative and negative gives you positive. This is 49 plus this one, this times this gives you negative 35. And we have negative 14. Now 14, negative 14, negative 14, we can bring them together because they are like terms. If you bring them together, we have 49, negative 49 here, and we have positive 49. And you see that if you resolve this, the answer will be 0. So we are saying that the factors that we are going to have will be such that when we evaluate the x at those points, the entire system becomes 0. And if you also look the case where x is equal to 2, the system will also become 0. Now for that of 2, if you put 2 here, this one will be 4. If you put 2 here, this one will be 10. So 4 plus 10 will give you 14. And here we have negative 14. So negative 14 plus positive 14 gives you 0. So in other words, we are saying that f of x is equal to x raised to power this plus 5. So this expression here that we have, we are saying that is the same, can be factored as x plus 7 and x minus 2. This is what we have. So when we are able to express this polynomial in form of these linear factors, we say that this is what we refer to as factorization. expressing the polynomial in form of 2, because this is quadratic, so 2 linear factors. If it is a cubic equation, we are going to have 3 linear factors. If it is a quadratic expression, we are going to have 4 linear factors. So now let's go ahead to consider other cases. I want the class to consider this other one, because this one is also pretty simple. Let's consider cases where the power is greater than 2. The power is greater than 2. And like that of the first one, the power is greater than 2. Let's consider that case. Let's consider that case where the power is greater than 2. Now in this case, we have, that's the first case here, we have f of x is equal to x raised to the power 3 plus 6x squared plus 5x minus 12. That is what we have. That is the polynomial that we have. That is a cubic equation. Now, in this case, it's not like quadratic equation where we will just think of 2 linear factors that we will get from the system. This is up to 3. So first of all, what you just go ahead, think of a number such that when you evaluate x at that point, the entire system becomes 0. Now in this case, you can start from negative or positive number. Let's start from 1. Let's start from 1. If you impute 1 here, if you impute 1 here, you will see that we have 1 raised to the power 3. This one you have 6 to 1 plus 5 to 1 minus 12. Minus 12. This one will give you 1. This one will give you plus 6. This one will give you plus 5. This minus 12. This plus this 7 plus this, you see that is 12 minus 12, which is 0. So you can see that 1 is a factor. 1 is a factor. S is equal to 1 is a factor. X is equal to 1 is a factor. Therefore, this is at this point it becomes 0. So you say x taking this to this other side minus 1 is a linear factor of that system. It's a linear factor of that system. X is equal to -1 is a linear factor of that system. So what do? We now use this. We use this now to divide by this so that we can reduce the order, the degree of that polynomial, so that we can look for the other linear factor, so that we can look for the other linear factors. Already we have found one which we have as x minus 1, which is also a linear factor of that expression. So we are saying that our f of x is equal to this one that we have is the same thing as now we have x minus 1 into a particular part such that it will look like this. If you open it up, it will look like this one. Now, how do we get that part? That part will be, we will get it by long division. And we have it as x minus 1 into, using this to divide this, so you say x cubed plus 6x squared plus 5x minus 12. Now, when you go through long division, we will be able to have, you will see that the degree of that polynomial will reduce by 1. It will reduce by 1. So what do? Think of a term such that when you use it to multiply this, you have this. That's just the method. Don't go ahead looking for plenty grammar. Just think of a term that you use in multiplying this, and that term is just x raised to power 2. X raised to power 2 to this will give you this term. That's all. So you have, when this times this will give you x raised to power 3. So that thing can go up after subtraction. This times this will give you negative x squared. When you subtract this from this and this will go off. Negative sign will come and embrace this, and this one will become positive. So this and this will give you 7x squared. You bring these ones down, 5x minus 12. Now also think of another number such that when you use in multiplying this, it will give you this term. And that number is simply 7x. If you use 7x to multiply this, you will have 7x squared here. So 7x here, if you use this to multiply this, you have negative 7, you have negative 7x. Now, if you subtract this from this, you are going to have this one and this one will go off. This one becomes positive and it becomes 12x minus 12. Now think of also another number that such that when you use to multiply this, it will look like this one. And that number is simply 12. 12 times this will give you 12x. 12 times this will give you negative 12. If you subtract this, you will see that everything will boil down to 0. So the term that we have, after dividing this polynomial by this linear factor that we have, this is what we have. So what we are going to have here is, we are saying that this expression is the same thing as this linear factor times this new quadratic equation that we have. If you open it up, you will see that you arrive at that answer. So this is what we have. So our interest, remember that our interest is to see how we can express this one as straight linear factors, because we have it as a cubic equation. Now we have been able to get one linear factor. Now we have a quadratic expression. So we have to rewrite this quadratic expression as two linear factors. This we can also do pretty simple. This we have done with our first exercise. Think of two numbers such that when you use it to multiply them, it will give you this and this. And those same numbers, when you add them, it will give you this. What are those numbers? What are those same numbers? If you add them, it will give you that. What are those numbers? What are those numbers? What are those numbers? What are those numbers? That if you add them, it will give you that. Those numbers, if you think critically, you see that is 4 and 3. Is 4 and 3. Positive 4 and positive 3x. So this expression here, we can, this quadratic equation, you can also write it as this plus 3x plus 4x plus 12. So that this plus this will give you this 7, and this times this will give you this expression. So these are what we want. So I can factor this out. This to this will give me this, and I say plus 3, such that this times this will give me this. Then plus 4 into x, this times this will give me this, plus 3, because these two brackets must be the same, it will also give me this. So what I have is just plus this, and taking one of these one, which is x plus 3. And so you see that this other part has also been factorized, written as two simple linear factors. So what we have here now, f of x, which is this, x is equal to 3 plus 6x squared plus 5x minus 12 is equal to x minus 1, which is one of the linear factors, and we have these other two as this plus 4 and this plus 3. So we are saying that if you open this up, you will be able to have this. Now in the other sense, we are saying that, or if we evaluate this expression at x equal to, because in this case here now we have done for that of x equal to negative 1. Okay, maybe we have not done that. We have done for that of x equal to negative 1 and it became 0. Now the other one we have is x is x plus 4 equals 0. So x will be equal to negative 4. L will be equal to negative 4. And the other one, x will also be equal to negative 3. And the first one we have x equal to positive 1. Now we have tried this. Now if you evaluate x at this point here now, you see that this entire entity will also become 0. So we are saying that we've been able to factorize this because these are all linear factors of that expression. These are all linear factors of that expression. The good idea that the concept that we're introducing here is that of a remainder theory, or factor theory, where this will also enable you to do some good works when we maybe go into partial fraction. The next one I want us to look at is that of the second one. Let's consider question number D. I have considered this. let me also consider this. Then the class with the concept that I'm using, the class can also be able to go through what I have done in a simple manner, because it's also pretty simple. Now let's consider question number D, which we have as 2x raised to the power 4. This one, the power has also increased. 2 raised to the power 4 minus 5x raised to the power 3 minus 15x raised to the power 2 plus 10 plus 10x plus 8. That is what we have. That is what we have. Now, in this case, what do? Our interest, because we are dealing with polynomial factorization, our interest is to see how we can rewrite this as 4 simple linear factors, because the power or the degree of that polynomial is up to 4. So we are going to have it in terms of 4 simple linear factors. So first of all, as we did in that of the previous case, we are going to just think of a number such that when you impute it into this expression, that system will boil down to 0. And what is that number? What is that number? Let's also go ahead by considering 1 to see. Let's consider 1 to see if it works. When x is equal to 1. When x is equal to 1, we have 2 into 1 minus 5 into 1. This is raised to the power 4. This is raised to the power 3. Minus 15. 1 raised to the power 2 plus 10 into 1 plus 8. If you did 1 times 1 into 4 is still 1, so you say times 2 we have 2 minus this one is also 1 times this we have 5 minus 15 because this one is also 1 plus 10 plus 8. Now if you look at this plus this negative give you 20, negative 20, but we have 2, negative 20. We have 10 here plus 10. 10 plus 8 will give you 18 here. 2 plus 8 will give you also 20. So you have 20 minus 20, which is equal to 0. So we are saying that if we evaluate x at equals 1, at f of 1, you will see that the entire system becomes 0. So in other words, we are saying that x minus 1, first of all, you say x is equal to 1, makes the entire system 0. So you say x minus 1 equal to 0 is a factor of that system. It's a factor of that system. So we are going to also go through the long division to see how we can reduce the polynomial to a smaller order, because this we have succeeded in writing as a linear factor. This we have as 1 x minus 1, and we have it in the other way. Now what are those expressions that ought to be here? So let's divide it through as we did in the first case, where we have this minus 1 into 2x raised to the power 4 minus 5x raised to the power 3 minus 15x squared plus 10x plus 8. That's what we have. So what we did, look for a number that when you use in multiplying, you have this. And that number is simply this. When you use this to multiply this, you have this. And you have this raised to the power 4. You choose to this, you have 2x 3. 2x raised to the power 3. You have that. You have 2x raised to the power 3. Now, you subtract this from this. Now, when you do that, this and this is off the job market. This one coming here, the negative sign coming here will make this one positive. So this one and this one will give you negative 3x raised to the power 3 minus 15x squared plus 10x plus 8. That's what we have. So think of from that number such that when you see multiplying this, you have this. And that is 3x raised to the power 2. When you use this to multiply this, you have 3x raised to the power 3. When you use this to multiply this, it becomes positive because of the negative number there, and you have 3x cubed. Now subtract this from this again. If you do that, this one and this one is off the job, and negative sign comes here. So the negative to this one becomes 18x squared plus 10x plus 8 plus 8. That's what you have. That's what you have. So the same thing again, we do think of a number that when you use a multiplying this, you have this, and if you do that, that is plus 18x. If you do that, you have 18x squared Use this to multiply this again, you have minus 18x. When you subtract this and this is off, this one becomes positive and you have 28x plus 8. Now think of another number such that when you use a multiplying, you have that, and that number is simply 28. That number is simply 28. When you use 28 to, when you use this becomes 18, this becomes negative 18. Sorry, it's negative 18 here. This becomes, when you introduce negative sign here, this one becomes negative 18. So the here is negative. So we are supposed to have negative 18 here. Sorry, we are supposed to have negative 18 up there. We are supposed to have negative 18 up there, negative 18 up there, negative 18. This and this is supposed to be negative 18. So when you multiply this and this negative 18, so when you use this to multiply, it becomes positive 18. It becomes positive 18. So that when you subtract this plus this, it's not 28, but rather you have, because this one becomes negative. So you have, if you use this to multiply this, it becomes positive 18. That's what you have. Positive 18. So this is what you have. Now when you subtract, you see that this one is off, this one becomes negative again. So you have negative 8x. It's negative 8x that you have. Negative 8x. Negative 8x, that's what you have. Negative 8x. So the next one is to think of a number that when you use the multiplying, you have this, and that is negative 8. And if you use the multiply, you have negative 8. You have negative 8x, sorry. Then you use this one to add the subtract this, you have positive 8. And if you subtract this again, you have 0. So this is what we are going to have in the next step. So this one multiplying this one gives us this entity. This is what we have, x raised to the power 3 minus 3x squared minus 18x minus 8. If you open this up, you are going to have this. But you can see that this side is also a cubic equation. So our interest is to also think of another number such that when we impute, it will give us another number such that when we impute, it will reduce the degree of that polynomial. It will reduce the degree of that polynomial. And let's consider a case where you say x is equal to negative 2. Let's consider a case where x is equal to negative 2. Let's consider a case where x is equal to negative 2. If we impute negative 2 into that one, we are going to have 2 into negative 2 all raised to the power 4 minus 5 into negative 2 raised to the power 3 minus 15 all into negative 2 raised to the power 2 plus 10x, that's negative 2 plus 8. Now, for the sake of time, we are going to stop here and we'll continue from this one in our next class. Thank you and God bless you.